Hello and welcome to another exciting episode of the Being an Engineer podcast. Today we have Rick James, the CEO of SimuTech Group, a seasoned engineer with over 25 years of experience in mechanical and electrical design. Under his leadership, SimuTech Group has become the #1 ANSYS partner in North America, helping companies across a variety of industries tackle complex engineering challenges through simulation-driven product development and design optimization, covering disciplines from FEA and CFD to optics and electromechanics. Rick holds a Doctor of Engineering in Engineering Management from Southern Methodist University, where he currently contributes to the Industrial Advisory Board. Today, he joins us to discuss leading technical teams, driving innovation with simulation, and shaping the future of simulation in engineering. Rick, thank you so much for joining us today.
Thank you for having me. I'm excited to dive in and talk about all these fun topics.
Yeah, let's nerd out. Okay, so first question I ask everyone is, what made you decide to become an engineer?
Well, I don't think I actually knew exactly what engineers did as a kid, but I had two grandfathers in rural Oklahoma that built a lot of things, and so I didn't know any different. I built my own go-kart when I was 7th grade, and then two-stroke centrifugal force clutch, and piece of oak for the brake. I mean, it was pretty low tech, but my parents encouraged me to build stuff. So I had a 3-story fort in the back of the house that was taller than our regular house. It had a fire pit, fireplace, and trapdoors and ceiling fans and electrical outlets, and
Oh my
it was
gosh,
ugly as anything.
that sounds amazing.
Yeah, I was like 11 or so, and I think when you don't know as a kid, you don't know what is appropriate socially, or I didn't know it was inappropriate to not build a 3-story fort. So it was. I remember my parents said it's time to take it down, and I was like, "You're right."
Oh wow,
It
you
served its
just went
purpose.
along with that, huh?
Yeah,
It didn't
yeah.
like tear part of your soul out to bring down this 3-story treehouse?
I think it's because it was such a patchwork of there was I grew up in San Antonio, Texas, and did a lot of new homes going in, and so I would literally attach a rope to my Huffy bike and haul lumber to my house. So it was always this like perpetual, oh, I found some more plywood, I can build a new level or something. So I think it was always a patchwork, and like I said, it served its purpose. And so I think it wasn't until really like shop in 7th grade where I started getting metal or other things, and like I'm not sure I was really that good at it. I just enjoyed it. I mean, that's the difference. I think a lot of people are like, and I was building model rockets that were within 10 feet accuracy on launch, and it just wasn't me. I was a little more sloppy, but I had fun doing it. So I think that was and I really thought I wanted to build houses. So architecture was really the route I wanted to go, and I was good at math. You're good enough at math. I wasn't the world's best student, and I remember talking to the dean at University of Texas because I was going to play football at UT, thinking about that at the time, and he was he had a lot of contempt towards the athletic department, and told me that it would probably take 7 years to get a bachelor's degree. Like, what? So I kind of settled on civil engineering at SMU, and 2 weeks before school started, they canceled civil engineering and said, "You're now mechanical." And I'd signed a letter of intent to run track, so I was kind of locked into the school, and said, "I guess I'll go with it." Didn't know much, and I recall my sophomore year finally taking heat transfer, and this ray of light came down from heaven, and God said, "You were meant to be a mechanical engineer, like heat transfer and." So like statics and dynamics, and which, you could be like on the structural side of civil, but I was just like, I'm where I belong. I love this stuff. So that's a little bit of a journey there between building forts and going to school. But
That's super interesting. I have a similar story, not the 3-story treehouse. I didn't have that level of skills in my fort building back then. But when I started college, I was in the manufacturing engineering
okay, yeah.
major. And honestly, I didn't know a lot about engineering at the time anyway. Like, I really didn't know what the difference was between manufacturing and mechanical engineering. So anyway, I got a scholarship to be in the manufacturing engineering department. So I said, oh, great, I'll do that. And then a year in, it got canceled, that major. And so the default was mechanical engineering after
Oh,
that. I was like,
funny.
oh, I don't know. Okay, great. Mechanical. I guess I'll do that then.
Yeah, that is one of those that there was a long controversy at SMU, not worth talking about, but um, it was one of those. I think ended up graduating with only 6 other people. It was
Wow.
very small school, but the department, I should say, the school was larger. So yeah. Anyways, it's interesting how schools kind of mess with people that way. You know, career paths and things. So
Yeah, yeah. It reminds me of the airlines these days. I feel like every time I get on or try to get on a flight, like half a day before, they tell me it's going to leave 3 hours later, and just all the schedules get messed up. Anyway, I'm getting sidetracked. So Rick, you are the CEO of SimuTech Group right now. Can you tell us a little bit about what is SimuTech and a little bit of the history? How did SimuTech come to be?
So I am the CEO. So SimuTech started, I guess, kind of formally, really as STI out of Rochester. So that was kind of the origins, and then through STI, Ken Lally, kind of the founder of SimuTech, really through the course of 7 or 8 acquisitions, which really brought together not just with the Rochester team, but the Seattle, the West Coast, and then you kind of go around geographically and get a lot of different. And some of that was just representative of the ANSYS Channel Partner network at the time, which was a lot of small players. And Ken had the vision of really seeing at the time there's a product called multiphysics, which really kind of was the premier product in the ANSYS product line of fluid structure electromagnetics, single license. It was like, how do you really cover that much? Like you can't, you got to scale to cover the product line just technically. How do you? I mean, I'm a hack at CFD, or at least I was. I had an undergrad class and I loved it, but I'm not an expert at it. So I think there's kind of successive story of looking at, hey, here's this small group of engineers that do a really good job of covering like the core finite element, and they're pretty good at these other things. And like, no, let's actually expand and grow. And I think that same methodology occurred. We just finished a merger with Ozone Engineering, and primarily West Coast operations, but they're across North America. But man, the talent we grabbed with that was pretty incredible. So just the amount of optics and electrical and RF. So it's one of these things that we keep getting bigger, and that's trying to keep up with the ANSYS product line as they expand. So I think ultimately that is to serve customers. I mean, it's one thing to get big, but you have to know the why. And the why is even when I stand in front of executives and explain to them, hey, why did you do this? And it's like, well, ultimately it's to serve you better. It's one thing to have one expert in explicit drop or ballistics or something, and now I have three. And that's small numbers on an absolute scale, but in terms of ability to serve a customer, that gets significantly better. So that's kind of a quick version, I guess, of the acquisition path of how we get to. We're about 220 employees right now.
Oh wow,
Um,
that's big.
yeah, and that's spread across. I don't know if we have half in offices and half out of their house. So it's definitely when I started, it was very in office culture. So that's been a big shift, much like every other company, and then the world probably post COVID. But there's definitely a culture to manage, an office culture and a non-office culture. But I think that's that common thread of really around ANSYS, but also around just doing really cool projects, whether that's related to the pre-sales environment, the application engineering, or the true just consulting. And there's obviously workflow development that's kind of a hybrid between those two. But that's that common thread that really drove all the acquisitions and the talent, and really there's territory, there's a business side of that, but those are kind of the core parts of bringing SimuTech together. Again, starting really in 2000, so we're kind of that 25-year mark as a company, which is meaningful, maybe more to us than our customers. We don't spout that too much, but
Well,
yeah,
congratulations. That's an incredible journey, and sounds like a lot more to come. Um, is SimuTech Group primarily focused on ANSYS, or maybe exclusively focused on ANSYS, or are there other simulation platforms that you consult on, that you're experts on as well?
we are. all ANSYS. We've taken an approach. If you go back maybe even 20 years, we were looking at alternatives. We thought, we need to broaden from ANSYS and we want to be a CAE provider. So we had a whole lot of different alternatives. And what we found was a lot of those are getting acquired by other OEMs like, Siemens, like FE-Safe, or, whatever, I can go name off a whole bunch that I got trained in, went through the process. And then as soon as another OEM buys them, like, man, flush all that effort down the toilet, just for competitive reasons with ANSYS. I think it became easier for us to tell ANSYS, hey, we're all in with you guys. And we want to be your number one partner, not just North America, but the world. And that's an aspirational statement. We got to earn it, from the business side, the competitive side. It's not just technical competence. But I think that's kind of the key elements for us, is just that's allowed us to focus. When you think about, well, there's a lot of system level tools out there. Should we be doing this? So I think some are even like MATLAB, like, look, it's a super, I don't say generic, but I say general tool that you can use. Like, we don't have to sell it or resell it or advocate for it to be experts in it. Just like SolidWorks or Creo or any of the CAD tools. So I think there's a lot of tools that I'd use the term a little loosely, experts in, like really good. I don't know, but we're not actually advocating. We're certainly not trying to help their bottom line. I think it's more like an engineering workload sort of thing. So that's, and I think even politically within ANSYS, I'm sure someone listening eventually, but we value that partnership and that relationship, and we want them to know that, hey, you're our one and only. When we're not going to go split. They don't have to worry about the competitive side or any of that. They're all in with us, I believe, and we kind of share that with them too. So
Yeah, I used to listen to a lot of like personal development type talks and coaching and things like that. There's this guy Brian Tracy back in the day, and I still remember his formula for success was to put all your eggs in one basket and then watch that basket. It sounds like that's the approach that SimuTech has taken, and it's worked out pretty well.
That's hadn't forgot that about Brian Tracy, but that certainly is true. And I think that the benefits of that, especially when you look at partnership, those are something I didn't necessarily foresee at the time. And again, this wasn't my unilateral decision or anything like that. But I do recall going to other partners, not to be nameless partners, their conference and their channel meetings, and thinking, they do not know physics. Oh, this is not right. This is not how you treat a channel. Like all these other things. So I'll give ANSYS some props. They certainly run a good channel program, and that made it easier to want to stay in and actually aspire. At one point we were kind of the bottom. I think we actually had to have the internal political will to grow and aspire to be number one through organic and acquisition. So. And again, number one it's just a number, but I think again, back to scale, those are those things that truly have meaning, that we see being able to handle our customer stats and these things that are more customer centric and not just nerd capability stuff, which I like also. But that's just kind of how we look at running a business and taking a long view of sharing our customers' success. Truly, we call it an emotional paycheck. Being able to watch, our largest customer launch rockets, and be able to know that you played this really small part of that. I mean, not even small, but hey, that's one of those buy-ins that you get, and it doesn't have to be a rocket. It can be a turbo machinery blade that you help shave off 0.1% because you optimize some, CFD back-end turbulence, cavitation problem, whatever, and to know that, hey, that's going to be in service for 30 years. The amount of carbon you save is huge.
That's a cool feeling.
Yeah, so I think there's this part, again, I think of the engineer personality that can typically understand that, hey, that is those are two different things, like watching a rocket launch and then watching, knowing you can't even see it, you just intellectually know, I feel really good about that.
Yeah.
And I think I try to espouse that, hey, like, this is in our world, in our SimuTech world, and engineering, and every employee needs to take ownership, not ownership, but feel that emotional paycheck. Like, hey, this is why, this is like our purpose. This is why we're here.
Yeah, we did
there's
this.
things that you can see and things you can't see, and they both matter.
How has acceptance of simulation, whether it's FEA or CFD or something else, how has acceptance of the market changed over the years? I don't know, 20, 30 years from now, what was it like then, and what's the dynamic in the market now?
Yeah, I think probably 10 different engineers have 10 different opinions, but you'll get one of those 10 here. I think what I saw early in my career. So prior to SimuTech, I worked at Texas Instruments, and then I worked at Sulzer in the heart valves division. So I used to help design heart valves and manufacturing equipment. And what I saw and again, not to that goes down certain names, but I saw a lot of companies that really saw simulation as a validation of a product development process. It was done at the end of the Gantt chart, so to speak, and it was planned at the end of the Gantt chart. And they put the smart guys and gals out with tape around their glasses in the back room and hit them maybe down in the basement and hey, what's the answer? We're about ready to ship the product. What's simulation say? Does it say it's good? We got any problems? And there's this kind of like proverbial nerd, the negative side of nerd, before nerd was cool, sort of thing that. So let's just say that to me is what I experienced, what I saw, let's say 30 years ago. Unfortunately, we still see that now, and that's one of the things that I like to do, just doing kind of not even a technical assessment, but just like super high upfront workflows. Where show me in your Gantt chart where simulation take place. And you can see the best companies that are like, oh yeah, the top of that V diagram, we're in the system configuration, and we're up here doing system architecture, and we can flow down from there, and we're doing the high level, and maybe not even model-based engineering, but just like, the upfront stuff. Even if it's linear, even if it's simplified, all that, you just see those are the companies that run really good engineering product development workflows. And we still have companies that tend to put it at the end. And I feel like those are, they're still getting value from it. It's a little hard, as somebody in my role to say that's bad. I can say that there's probably room to improve. It's not just a diplomatic statement, but I think it's the most honest statement I could say. We don't tell customers how to develop their products. We enable workflow and tools. That's kind of the philosophical approach to kind of our role at SimuTech. But now, if we're invited in, which we are many times at customers, we have close to 2,500 active customers right now. So our scale is big. In our influence, which we take as a heavy responsibility. It's a big responsibility and a big that we want to give good advice and we want to help customers. But again, we're not there to tell customers how to develop their products. I've made that mistake many times where I've been side-eyed, like I was a little too excited to go tell them how to change the durometer of their drop test polymer shape, and I was not there. I was uninvited into that, and I did not know it until an hour into realizing, why am I the only one talking? That's plenty of mistakes I've made in my career, but that's
Next time,
I
bring
think
a few pictures of your 3-story treehouse to provide some clout, right? Like I know what I'm talking about. I did with this
I
when I was
know,
11 years old.
I know. That's funny. I even had concrete floors, but
Fireplace and yeah. Um, how about the tools in simulation? I mean, has it the core functionality, has it more or less stayed the same over the past few decades, or have there been like pretty significant, substantial changes and improvements in the capability of the software?
I think there's certainly the core physics, across the product line, not just like core mechanical FEA, but certainly CFD and the signal integrity, antenna, RF, the whole, even optics, from photonics optics, you kind of keep expanding the breadth and depth of the physics. So, but if I can take one of those, even look at FEA, the one that I'm most associated with. FEA, I learned, mid '90s nonlinear. You had nonlinear, three forms of nonlinear. Turns out how you count it, but okay, they'll say three. I don't think that's there's been certainly improvements, but that's been around 30 years. So from that perspective, there's not a huge difference. I think the difference is really the integration with what we say is multiple physics and multi-physics. So there's plenty of customers that they have a really strong structures team, and they have a really strong thermal team, which could be fluid, could be the structural side, convection or conduction, and then the fluid side, and they have these. So that's kind of multiple. Then multi-physics, again, in my terminology, is where maybe you're actually code coupling. I'm doing fluid structure interaction or flow induced vibration, merging those. So I think that and even that's been around for 20 years. So I think it's just this perpetual integration of how those physics talk to each other, and that platform, not just like doing scalar functions of like, hey, this parameter is 4 and pass it back and forth in some ASCII text, like, but actually doing full field, 3D code coupling. That's still pretty cool. And I'd say it's pretty cutting edge. Again, it's been out for a really long period of time. We don't see a whole lot of customers doing that. And then you have this tier of customers that are just truly high end, and they don't do it because it's cool. They do it because they need it. Right? You're able to make less assumptions on your boundary conditions. Let's say on the structure side, if you're really got a coupled fluid system driving it, or even on the antenna side, if you're doing consumer electronics, and people used to do antennas a lot, and guess what? Some of those antennas, they crank out some serious heat. So it used to be maybe they would get like a handheld convection coefficient, or just a 5 watts per centimeter square, whatever sort of flux, and they would go. And now, why do that? You can actually actually map those direct fields on those non-spatially varying fields. Again, that's always been available, in the last, let's say, 10, 20 years. I think the ease of use of setting up, again, so now it's maybe workflow. I mean, that's maybe the summary point here. Before that was like a 2-week project to go couple it up, and now that's maybe a little more drag and drop. And again, I'm also speaking of the ANSYS platform, so admitting that there's certainly other platforms, and they have, the other big guys have their levels of integration, but at least from my perspective, seeing a single platform, one of the leading one, as it's developed over the last couple decades, really integration and speed has been as well as core physics, but integration speed have been the real key.
Yeah. You mentioned workflow. If it was up to you, if 100% of your customers came to you and said, Rick, how do we incorporate ANSYS? What you tell us, what's the workflow? What do you think the ideal workflow is?
Man, I just got that the question on Thursday from a customer up in Seattle. Yeah, I think that part of it is, one way of viewing it is, well, benchmarking your workflow now. It's sort of the science of better. If your workflow now takes you 2 weeks to get a good answer that you feel good about, or validated, or whatever, not the physical test side, but on the simulation side, is 10% improvement, is that good enough? It's a 10x improvement. So I think there's kind of like setting a realistic expectation that's unique to every company, is like, hey, what's a reasonable improvement? If I kind of move to the method, certainly I think one of the methods for workflow, the how that you do that, I think there is really the let's say prevalence, the explosion of Python, of just like even nested Python, and you're just like Python within Python within Python, and calling each other, and it's really powerful. And I think ANSYS has a great roadmap in that, with integrating Python into every one of the product lines, just so really that it's scriptable. Everything's not a GUI pick, and it's just something that you stay within that GUI, and you insert and you click buttons and you get an answer, and you print screen or whatever, and you have your answer. But I think, again, looking at that from an architecture perspective, being able to have individual software tools that actually can code couple, not just in that multi-physics example, but actually looking at from a system perspective, where you can go pull these scalar values out, and you can go put that to a reduced order model, put these into real-time systems. So there's things like that you can do once you have that core system that's more, I want to say something besides Python, it's not coming to me, but ASCII or something, simplified, text-based. So it's just so much power in that.
Where are engineering teams using simulation today that they weren't 20, 30 years ago?
I think certainly if I look at the development tools, RF has been around, simulation and RF has been around that long. So I think it's tricky in the sense that what is is it the prevalence or the quantity? Because it's still amazing to me how many people shun simulation for build and test, which I'd love to talk more about. And I have huge respect, and I think that you need physical test in a product development workflow, and that's certainly my personal experience outside of the simulation space. You got to have that combo, but I don't have a great answer for you, honestly, because it seems like it's I could look at where ANSYS is really invested technology. But even if you go like explicit dynamics, they're like, oh, a lot of stuff's been around. Go back in the early days, and it might have been like, or even Nastran, like you go pull out of NASA and say, well, it was Mogul again, sort of old school, and yet that's still around. What happened? I don't know. You got like 1,000,000x more people using it. It's become embedded in the workflow of so many different companies. So I don't know. I think that I'd probably give you a pretty weak answer there. But
Well, let me ask you about this. You mentioned that there is some aversion to using simulation, and of course, sounds like you're recommending both physical hardware testing in conjunction with simulation. Why do you think that this aversion still remains? Like, what's the, I don't know, the mindset or the hurdles that engineering teams are not overcoming?
yeah, I mean, there's plenty of people out there that have made a big business decision based on faulty simulation data, and those memories are long. so so I will acknowledge that anytime you have something that was key to making a bad decision that you trusted, that trust is violated, even if that trust should have been put into an engineer or a culture or a workflow or these other things, but to put it into a technology, to me, is misplaced. And I even had a professor telling me that I was undergrad, and he was ragging on FEA because he saw a spoke on a bicycle on the bottom one, and FEA said it was in tension, and everybody knows that bicycle spokes aren't in tension. And I remember thinking, so therefore, the conclusion, therefore, FEA is wrong. And I remember thinking, unless it was pre-tensioned really tightly, I was thinking it depends, but I'm like trying not to defend the technology, but just like kind of a natural challenger. And I was thinking, or unless it was pre-tensioned and you did a 2 load step and you pre-shrunk, so I think, but you're never going to convince that professor that finite element is a valid tool and could be used in the workplace and commercial. It's great for academics. So yeah. I think that people have their independent biases. And I think that to some degree, look, the value of simulation is really economics. I mean, it's kind of a personal opinion about, unless you're a national lab or government agency or school, like where you're really, you're probably not driving economic driven. Maybe you have other goals. I mean, the government their goal isn't to optimize profits. So I think that's kind of if you're going to use this, and if build and test is a better route, and a lot of people believe that the physics are so complex you couldn't even possibly handle this. And I think, yeah, maybe you're right, but I think also it can shed insight. And I think if you look at a simulation as something to tell you the exact right answer, or to tell you you have a 3x3 matrix of design, and I heard this example of somebody doing White Sands missile test, and they were doing a 3x3 matrix, and they used an explicit dynamics tool to go essentially eliminate the worst 4 contenders. It was $1 million a test. So they weren't getting it wasn't a simulation or test example. It was hey, how do I optimize my financial situation using simulation that I'm still going to make it based on physical test? So I think that a lot of people tend to have a binary kind of, is it this or that? And where possible, I hope that myself or anybody else at SimuTech would bring people along and dive a little deeper, use curiosity to understand and make it not confrontational, but so, better word than binary, but so stark. Like, is it this or that? And hey, look, these play off each other, and like a really good simulation tool has validated test data. And that's invaluable. I mean, that makes the simulation so much more valuable. Even when you're starting looking at, downstream stuff, digital twin, IoT, those sorts of methodologies, or I should really say mindsets, um, but that's kind of an approach that I think we kind of espouse, that we have to be invited into that. That's not something we just go like preach from the hills. But I think that um, I think it's certainly when we're invited in, I think that's a pretty common approach that we'll take on simulation versus test.
Yeah. Let's talk about AI and simulation. Obviously, AI is like this huge thing now. Everyone's using it for different purposes, and it's starting to make its way into more and more engineering, right? Uh, there aren't a ton of like, in my opinion, really um, uh, powerful, meaningful AI tools yet, but they are starting to creep in for sure into engineering. How is AI changing simulation? And like maybe 5 years from now, how do you think simulation is going to, what's it going to be like AI powered?
Yeah, that's a great question. I'm really kind of not on the sidelines, but I'm really curious too. I think we've done certainly a lot of research with like the earlier comments about the within the ANSYS product line, and even kind of the product line of what they're looking to do in 2026. But I think in the broader question, that the real way that I see it right now is just in chatbots. That I think being able to use it for tech support or standards, or I think there's kind of the perimeter of simulation that's just kind of maybe check my scripts. We were talking about Python scripts, being able to take that. I kind of, maybe that's a secondary kind of thing of maybe what you're looking at or asking about. The way we see the AI is not so much on what it does, but what problem does it solve. And we had a customer say, "Hey, we've got these assemblies. We've modeled our whole system with ANSYS, and we'd like to do some derivatives, but we'd like it to design itself. Can it do that?" And I remember thinking at this first level, like, what? And then I thought, you know what? That's actually a great aspirational statement. That if you take something that's I'm doing generic here, but like you got a 10-foot design, I'm going to make a 15-foot, and all those components or subcomponents, like they just scale themselves, all based on requirements, either at the component level or can I make it level. Like there's a lot of things I think that. So again, that's a super abstract. I get, but I thought that was a good thing when I think about what can AI do. So I think what we do, a lot of customers like, hey, I want these benefits of AI right now, and we try to push them towards parametric optimization. And again, that kind of, you have to predefine the space. I'm going to vary a radius or material property or something along those lines. And then there's the discrete number of solves that goes out. And I think part of that is that the AI landscape really is it's new. It's really new. So I think we're super excited about it. We've got our toes in it. We're working with ANSYS and doing some of their benchmarking, and we're waiting to feel better about the full benefits, like the production worthiness of that. But I think it's interesting when you think about, well, what is it that AI will do that the parametric optimization won't? And a lot of it's, I think, if I can build this database, I can keep building this database. Let's say, I don't know, automotive, trucks. I get this database of trucks, and I just keep doing iteration after iteration, and they're small variants, and I keep building this database, and I keep training it. Pretty soon, in that class of problems, I can just refer back and get an answer that, let's say, within 10%, 5%, or whatever that sort of correction. If you want that upfront design, but again, if your lot of design is not 3% accurate, I'm looking for something that's directionally accurate, but it's something better than directionally accurate. So I think that's where AI is going to take that, is being able to have this, call it machine learning, call it whatever buzzword you want, but being able to have this database that you can keep referring to and keep doing super fast analysis. So speed is always king. But I think ANSYS did a survey of their users. It's probably been over 10 years now, What's the one reason? What's the one feature that you need ANSYS to be no matter what? Is it changes and over the years? And I think it was somewhere like 86% of the people said it has to be the right answer. And I think that's also kind of those are our peeps. That there's designers. My first job was with PTC out of school, and they had all these like rules of thumb, and it was, designers are paid to be right, and analysts are paid to not be wrong, which is kind of like a double negative. But I think it kind of illustrates some of that. That like if you're going to do simulation, you have to care about the right answer. And if the right answer doesn't matter, then why are you trying? So I do think that there's an element of like how can you ensure accuracy, and even maybe the other way of asking it is say, what accuracy do you need in order to make a decision? Because the fact of a simulation is the stress is 4 versus 5. What do you need to make a decision? So I think if you work backwards from not just meeting a requirement, which actually maybe that is a decision, but I'm saying at the kind of the totality of a product development workflow is usually to develop a qualified product that meets certain quality specs that moves to manufacturing or moves to a derivative. So I think that having that, how does AI help you make decisions? I think that's the real key. And how exactly the workflows are going to work out, I'd say it's a little new right now. There's plenty of things you can call AI, and maybe I'm taking too narrow of a definition. Like I said, there's AI with like chatbots and helping in that, and there's certainly agentic that can do things that are really cool too. But if I really get to the simulation driven AI, I think it's going to be really interesting how AI can make decisions with engineers and maybe for engineers. And I think we're in front of that. Like it's a little hard. In 5 years to me seems like a thick fog. I
Yeah,
think
everything's changing so fast.
oh yeah, big time. So
Yeah.
I think that it'd be interesting to see what happens in the early 26 with that.
Can you think of a story that you can share where a success story, right? Where the application was just perfect for simulation and your team was able to save a company a lot of money or time, but like what's a great example of a big win using simulation?
Yeah, I'll be a little generic with the customer, but it was a pretty advanced aerospace application, and the users are really good in terms of like their methodologies were sound, they're accurate, they're well trained, they had good hardware, and quite simply, we went in and looked and using Python and just automated. It took their process down from 4 days to a couple hours,
Wow.
and some of that, the 4 days parts, that was maybe from them, so maybe they were helping us out on our metrics, but it was definitely a lot of individual decisions and a lot of like human handing off to other humans. So I think if you really broke down that Python script, it really encapsulated a lot of their decision making that I think was a verbal process, and actually be able to put that into I don't know, code. You encode a certain level of decision, and some of that had to do with looking at multiple load steps, like in a fatigue fracture domain. So a lot of times you're doing cycle counting, and I've got lots of different. I've got a few different models I'm pulling from. I've got to accumulate those cycles to get like what's the remaining life of this product. Those are scriptable methods, I should say. So I think that, again, I think if there's a common thread there, even to earlier commentaries, are really about Python and automation. It's just that it's so pervasive right now for us.
For engineers out there listening to this who maybe don't have any experience, maybe a little of exposure, but they've never used ANSYS or simulation in general, but they're really interested in at least dipping their toe in the water and getting some experience. What's a good way to get started that's not too overwhelming, but how do you just get started?
Whew, good one. I think if you're working for a company, I define find the people in that department and go tell them, hey, I think what you do is cool. I'd love to learn more. Can I shout at you? There's certainly that element. Maybe if you're a student, I don't think I was till grad school that I took any classes on finite element. I think just strength of materials, mechanical engineering stuff. Just knowing mechanics overall, just really good fundamental sound theory. I think just being able to, there's coursework kind of angle, but maybe that's a little too obvious. I think there's certainly downloading the student versions of ANSYS. Yeah, there's demo models in there. There's things you can take. There's a whole lot of free resources online. ANSYS does a really nice job. Focus a little bit more on the learning side, not teaching you how to get trained on the product, but actually just the overall learning that ANSYS has out there, that's coupled with short-term trials of the product. But there's other software that can do that too. So I think part of that's just playing with it. Like I think the other thing is having a problem to solve. It's one thing to get in and like, I'd like to rotate this really cool animation, and that's really cool. I think if you're like, hey, I'd really like to build a go-kart out of wood, can I do it? You're having a problem to solve. I tried making a brisket smoker out of wood. I thought, could I do it? So I actually started modeling that inside of CFX just to see if I could get like the optimal smoke, into my brisket. Because as a Texan, you got to get the brisket right. So it actually worked out. It didn't burn it down. And part of the trick there wasn't the thermal, but actually the smoke. I would try where does the smoke go? Where does that flow? So I actually did fully model. I've done a couple different smokers with CFD. But I was trying to solve a specific problem. Now, again, I was already pretty good at CFD when I was doing this, but I think for new people, it'd be really cool. That way it gives you a little more of a goal and actually a little more satisfaction. Maybe importantly, if you're looking for a job or it's a senior project or something like that, you have a great story to tell. Hey, yeah, I modeled this. I don't know if you've seen it on YouTube, but it's really cool. Right? The Lego Formula One that smashes in the walls. And then they modeled it with explosive dynamics and watch that, and they can see the parallel between the real and the simulated. So I think just having a specific problem to solve would be a really great place to solve whatever the physics. And there's plenty of tools out there and plenty of learning. It's just a matter of having the background, the gumption, the discipline, and asking for help, the right person. So those are kind of the keys. But yeah, great. I'd love for people to get out there because it's simulation. I think it's not just that it's a key part of any modern product development process, but the younger you start, the more that gets into your mindset, the easier that is to let that be second nature when you are developing a product. Is not even a simulation, but just like capturing the essence of a product before you design it, so that you can play with it virtually and do 10,000 times more iterations before you get the physical test. So I'm a fanboy. So.
I love your smoker example. I hope your marketing team got some good pictures and video of that and used it. That's such a great practical and fun use for simulation.
I did one too with thermal wool on the inside of a green egg, and I have thermal imaging of that. So I do believe in my own empirical data as well. So
nice. All right. Well, I just have, I think, just one more question, and then we'll kind of wrap things up here. I've never really used simulation, but I worked at a company where there was a whole simulation department. It was an engineering services company here in the Southwest, and there was a pretty substantial simulation department. So I was exposed to it a lot, and there were people I talked to who were using it every single day. And I remember that, at least then, this was probably 15, 20 years ago, to run ANSYS or any simulation program effectively, you really needed like a very powerful computing machine. Is that still the case, or are there like cloud applications now that will do a lot of that number crunching, processing horsepower for you, and maybe the computer you're on driving doesn't need to be as powerful as it used to be?
Yeah, so there's a ton of options. I think the ultimate question really comes almost like, well, if you're a business and you're making an investment in simulation software, what ratio would be hardware? That's one way of looking at it. I think there's also the certain mindsets are like, well, computers are cheaper than humans. Just mesh bomb it, like throw tons of mesh and don't spend much time cleaning the geometry up. Just throw it to the cluster and let it do its thing. There's certainly some people that have that mentality. Sometimes the opposite, you spend a ton of time in the mesh just to get it so the solve time is really, really small. And, obviously GPU and cloud. So that's kind of the landscape. A lot of it has to do with OpEx, CapEx. a lot of if companies are really tied on capex, that maybe not in a support group. Usually, support groups that we see tend to have a decent budget for capex, but a lot of product groups they're really limited on capex, but they have a ton of opex. So if they need to go blow $5,000, $10,000 a month on cloud computing, that's a green light for them. And so they might have a high-end laptop with a good amount of RAM and good for pre-processing, post-processing, report writing, but all the heavy lifting, and actually maybe for some front-end solves just to prove to see is it going to converge, and they take 15 minutes just to kind of kick it off a little bit, and once they say it's good, they crank it over to the cloud or on-site on-prem server. We tend to do a lot. We have a really healthy install within SimuTech, but we also use the cloud. There's a certain point where we're not going to design for max peak loading, so we try to stay connected with top few providers, and just whatever our percentage is. Sometimes it's 3% of max, sometimes it's 20% on any one, and that a lot of times too, customers come to us and say, we really want to we need to expedite this, and we're like, well, great, this is our option. We're going to go to this cloud, and even if that's ITAR or government, again, we're CMMC level 2 certified. So if there are some pretty strict requirements for government contracting, that's something we do, and obviously the computer environment has to go with that. So GPUs are the ones that get a lot of questions about. I love GPUs. I love the premise of them. There's a class of applications that they're epic for. The on chip or on GPU RAM tends to be sometimes a limitation, and I know that's being able to couple those together and get those GPUs together and extend that effective RAM. That's a key area a lot of the hardware people are spending time on. So again, I think we're our role in terms of having this heterogeneous network of what our customers use and what we use internally. We try to match that, and we see everything just keeps getting more of. So we'll see how that goes when you look at NVIDIA and their stratospheric rise, but it just keeps looking good for them.
Well, terrific. Rick, thank you so much for being here with us today and sharing about simulation and how engineers are using it and can use it and will be using it in the future. Is there anything else that you'd like to touch on before we wrap it up today?
No, I think that I think for me personally, one of the things that I love about simulation is being able to have impact, even in the role we have now, on product development workflow, and being able to know that the simulation, you're truly having a piece of our customer success, and being able to look at that from every industry, whether it's photolithography equipment for semiconductors, across the board. But I think just when I think about an engineering profession, when I think about being able to have impact and being able to drive optimal products, simulation, it's not the only way, but it's a phenomenal way. I've been in professions or careers or jobs, that really simulation was secondary, and I kept feeling like simulation really should be a part of every product development workflow. So I'm an advocate for the industry, but I look forward to any sort of feedback that you guys have. There's certainly excitement I have for helping people develop in their career.
Terrific. Well, along those lines, how can people get in touch with you and or SimuTech Group?
SimuTechGroup.com. You got that one right. That's our website. Certainly go there, but I'd love to connect with anybody. The easiest way is go search Rick James and SimuTech. I think there's only one. Lots of Rick Jameses out there, only Rick James SimuTech. So feel free. I'd love to connect with you guys and send me a comment. Tell me what you loved or interested in, or what you'd like to do with your career, and I'd love to see if there's any way I could help.
Wonderful. Rick, thank you so much for being on the show today.
Thank you.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.